Hello everyone. In this video we are going to talk about the scatter plot. The scatter plot is used to display the relationship between two numeric variables. So you have one numeric variable mapped on x-axis, another numeric variable mapped on y-axis, and each point on the scatter plot is the intersection of the x-coordinate value and the y-coordinate value. So let's get started. So you need a tidyverse library. The data set that we will be working on is the movies data set. You will also find a copy of this file on the GitHub. If you want, you can download it or you can directly access it with the read.csv function. Fine. Now let me first show you how the data looks like. Now you can see that it has all the information related to the movies, and in particular I will be interested in these two variables. The first one is the gross revenue and the second one is the duration. So I'm interested in looking at, is there any relationship between the duration of the movie and the gross revenue that it has generated. So in particular, if the long duration movies gives the more revenue compared to the short duration movies. So these two variables I'm going to use to plot the scatter plot. Right. So I want to use one variable on x-axis and another one on the y-axis. So before we start using the ggplot function, I would like to first check how the different column names looks like, because most of the time what happens is that if you type in the column names, then you will end up sometimes in a spelling mistake and the scatter plot will not work. So instead of doing that, I want to copy the column names for the x and y axis. So I'm going to use the column names function, movies column names. Now this will help me to simply copy paste the variables for the x and y axis. Now we are going to start generating the scatter plot. So as we have learned in the last video, the ggplot function uses the grammar of graphics. It uses different layers. So we are going to start with our base layer, which is a data. So in this case, data equal to movies. And we also learned that the next layer always starts with a plus symbol. So plus, the next layer will be the aesthetic layer. In this case, I'm going to map the variables to the x and y axis. So x axis, I will be using the duration variable, and for the y axis, I will be using a gross revenue variable. Okay. And comes the third layer, which is a geometric object. In this case, it will be the point. Yeah, so let's plot this. So this is the scatter plot that's been generated. As you can see that I have a duration of movies on x-axis and the gross revenue on y-axis. So it looks like there is some kind of a relationship, but that is not a strong kind of a relationship. So there are a few things to observe here. The first thing is that you see lots of points here between let's say 50 minutes to around 170 minutes. So most of your movies, are in between these two durations, around 60 minutes to 120, 150, 160 minutes. So that's why you see a big chunk of data been displayed in this time window. And the other thing that I always recommend, especially in case of a scatter plot, is to change the background theme. I always use a white background theme for the plots because it looks very appealing. So I will change the theme with the help of another layer called theme_light. Okay, and if I execute this, now you will see the theme is changed. Now you can see the scatter plot looks more appealing, and it's very easy to check the distribution of the points on the scatter plot. Fine. So we have end up with lot many points here between 60 minutes and 160 minutes of duration. This large mass of points that you see may cause some confusions because it's very hard to tell the true number of points that are plotted. So this is called as a overplotting, and this actually it corresponds to the point being plotted on top of each other over and over again. So when you have this kind of overplotting, it's very difficult to know the number of points being plotted. Now there are two methods to address this overplotting issue. The first method is changing the transparency of the points, and the second method is adding a small jitter. Jitter is nothing but a small nudge or the random nudge that is added to each point. Let's see these two methods now to avoid the overplotting, starting with changing the transparency of the points. So let's start by changing the transparency of the points. So let me first copy this entire code, and in the geom point function I'm going to use alpha argument. So this alpha argument decides the transparency of the point. Alpha equal to 0, that means it's 100% transparent. Alpha equal to 1 is 100% opaque. Now if I use alpha equal to 0.2, let's see what happens. Now you can see the transparency of the points being changed, and you now start getting sort of more clarity in terms of how many points exactly being plotted on this region between 70 minutes and 160 minutes. So that is one way of getting rid of transparency. The second way of getting rid of transparency is using a jitter argument. Now jittering means giving each point a small nudge in random direction. So you can think of jittering as shaking the points around a bit, and due to this random shaking or random nudge that you add to each point, the points get perturbed with respect to each other, thereby reducing the overplotting. So that's the concept of jittering. Now let me now show you how to add the jitter to the scatter plot. So let me copy this code first, and now instead of geometric object point I will use jitter, and let me remove this alpha argument as well. Fine. Now let's execute. Now you can see that the points, those were superimposed, have given a small random nudge, and because that small random nudge, those points have changed their position with respect to each other, and the overplotting in the scatter plot now are considerably reduced. Okay, fine. Now if we want to check the trend of the two numerical variables on the scatter plot, we can do that with the help of a smooth line, by adding a smooth line to the plot with the help of geom smooth layer. So let's now add the trend line to the scatter plot with the geom smooth layer. So let me copy this code, and I am going to add another layer, geom smooth. So let's execute this. Now you can see a trend line. The scatter plot is now overlaid with the help of smooth curve, and the uncertainty in the form of pointwise confidence intervals is shown in gray color. Fine. Now the geom smooth function uses methods argument, and the method argument decides which type of model is used to fit the smooth curve. Now by default, method uses the smooth local regression function, but we can change the method. There are many other models that can be used to fit the line. For example, GAM, generalized additive model. Then there is a LM, linear model, or there is also RLM, which is called robust fitting algorithm. Now let me show you. For our case, I think the LM method would be more appropriate because the relationship looks like a linear relationship. So I'm going to use the LM method. So inside geom smooth function, I will use the argument called method LM. Now let's see. Now you can see the best fitted line being displayed on the scatter plot using LM method. If you don't want to show the standard error, then you can use AC equal to false argument, and it will only show the line. It won't show you the standard error. Okay. Now, if you are more interested statistically to find out the relationship between these two variables, you can do so with the help of Pearson correlation. So movies, I'm going to use correlation function between gross revenue and the duration and use equal to complete dot observation. So this will take care of missing values because correlation function doesn't work on the missing values. So what you have to do with the missing values, you will also have to explicitly tell to the correlation function. Now here I'm telling that you use only the complete observations. That means all those observations which doesn't have the missing values in them. And you will have to use the curly brackets here because correlation function doesn't work well with the pipe operator. So we need to change this into the expression. So for that we use a curly brackets. Now let me execute this and you can see that the Pearson's correlation is 0.24. So it has sort of a weak positive correlation between the gross revenue and the movie duration. Fine, so let's summarize quickly. Scatter plot is used to visualize the relationship between two numeric variables. The scatter plots, if there are many points plotted on a small region, then we end up with overplotting phenomenon. We can use geom jitter layer, which gives a small random nudge to the data to avoid overplotting. By the way, one thing I missed is that even if you give a small random nudge or noise to the data, it's only for the representation purpose. The actual values of those observations in the dataset doesn't change. Geom jitter is only used to avoid overplotting and showing those points clearly on the scatter plot. It is nothing to do with the values on the actual dataset. The values on the actual dataset doesn't change because of geom jitter. So that's a very important point to note. Geom smooth adds a trend line to the scatter plot. Based on the method that you select, it adds the trend line. In this case, we use linear model method because we found out that there is a good linear relationship between these two variables, but there are other methods also available. For example, GLM method or the robust linear model method. And finally, the alpha parameter we used. We changed the transparency of the points. That also helped us in avoid overplotting. Thank you very much for watching till the end. If you like this video, you may like to subscribe it. And also, I am more interested in your comments. Do you like these videos? Are there any improvements that are required? Please write your comments in the comment section. I would be very happy, I would be very glad to read those comments and improve upon my content based upon your suggestions and feedback. Thank you very much. I will see you soon.